some of the nitty-gritty of inversion control and dependency injection around some of the use cases in the why as well. For inversion control, one of the main benefits here is that we're isolating our individual classes. They're no longer responsible for understanding the inner workings of how the other classes work. So in this example, if I have a service class and it's reliant upon a repository, it's no longer responsible for providing any information that a repository needs to work. And it's also able to be a little bit more loosely coupled in that sense. And as an example of this, we can actually look at a use case where I have a service that has an interface that is dependent upon. And by using inversion of control, we're able to allow whatever class is instantiating the service to choose an implementation to satisfy that interface, as long as the implementing class is able to fulfill the interface's methods. In this case, just like a get data by ID, representing like a basic database query. Then we can use any of the implementations that are available and our service remains unaffected, right? So high-level picture inversion of control is just taking the responsibility of creating dependencies away from the class that has the dependencies and hoisting them outward. But really one of the main problems with this becomes that without a framework to manage this, it'll quickly become, wow, that really did not translate well to a PDF. Okay, I was trying to illustrate a dependency tree here. But imagine that we have one class at the top of my application, and that class is responsible for creating all these other classes underneath it. Well, then suddenly, if we're using inversion of control, we get the benefit of these lower classes like A and B here. They aren't responsible for creating their dependencies, but suddenly we're taking all that responsibility and we're pushing it up to that top level class. And so we're adding a bunch of complexity and a bunch of perhaps like leaky abstraction. We're not keeping a good separation between our classes in place. And this is kind of why we step into the need for a framework or a solution like dependency injection. So if inversion of control is simply taking the responsibility of creating those dependencies out to a different class, dependency injection is taking it and putting it completely separate from the classes in my application into a central context. And so what I kind of want to do is actually walk through a little bit of how that works. So if you've used any modern or most modern development frameworks, a lot of them will use dependency injection already. If you use Spring, we've got auto-wired and beans. If you use Angular, you've got dependency injection there. Even .NET has different forms of dependency injection. But what I wanted to do here actually, though, is walk through how that works. So at a high level, dependency injection sets up a container. And this container class is responsible for registering any classes that need to be injected as dependencies throughout our application. And so what will actually happen is, let me pull up the code here. So if I have a service, and that service requires, or a class that has a dependency, right? So in this case, I have a controller, and that controller has a service that it's reliant upon. What I want to do is I want to be able to identify the classes that need to be injected into my application, and I want to be able to register them to a context and a class that manages all of that, so that I can go ask it to say, hey, can you go get that for me? Can you go provide that to me so that I can use it as a dependency here without having to worry about it? And the way that we do that with dependency injection is usually by using different annotations to identify these things. So in the case of this project, I've created an annotation called an injectable that is used to identify services or classes that can be injected or should be rather registered to a container, to that context, and then an inject annotation that will be used to identify and actually put them in and provide them. So what I kind of wanted to do is just walk through how this might work, maybe do a little bit of debugging, and talk through how the dependency injection actually works in an application to hopefully get a better understanding of that. So in essence, what I've done is I have an app class here, and it's creating a container class. In other applications, in other frameworks, obviously they'll do this behind the scenes for you. But creating that container class allows us to start registering dependencies to it. And so when it creates, we're basically going to create a way to track different class field types and then the instances of those classes that go with it into this class map here. And then basically what we want to do, what it's doing is, if I can go to, so it's actually going to use a, we're going to go scan through the class path of our application and look for any of the annotations that we created to be able to identify the fields that need to be registered to our context at startup. So what it's doing is as soon as the application starts, we're going to scan all the classes in our class path and look for fields and types that use these annotations and then register them to our context here. It's going to check to see if we already have it. And if we don't, then it's going to actually initialize the class using reflection. And since the container needs to be sort of able to work arbitrarily of like what kind of classes and dependencies that we have, it uses a lot of generic types to be able to represent what data that we're going to be using. And so a lot of this actually uses the principle of like reflection and object-oriented programming, which is to say that I can look at a type and then access the fields on that type and be able to observe them without having to instantiate an object of that class or an instance of that class.
I'm so sorry.
Oh, that was you. Okay, I was worried that our HDMI cable died there for a second.
I'm trying to make it a little bit darker on the screen so we can see it.
All good. So when we're referencing this class of this generic T that we have here, what we're really doing is we're passing a, for example, a .class value to it, if you're familiar with that in Java. And the idea essentially is that we're passing the type of the object and not the object to it, so that we're able to look at the different fields on it. Once we have that, we're actually looking first at the constructors to see if we have any parameters in there that need to be injected. And then we're able to look at each parameter within the constructor using reflection to check the type and then instantiate the type of that. And then essentially, if we have in our container already registered, we have an instance of that class, we can return it. And if we don't, then we can actually go ahead and add that class to our container by invoking the constructor with the other parameters that we have. It's a lot of, like I said, very Java generic stuff, but the basic idea of the flow of it, right, is that we're going to go look for everything that we've marked as injectable, and then we're going to look at what we need to be able to create those classes, and then basically use recursion to go through each injectable thing that we have and then instantiate them. And then from the bottom up, we're going to create the instance, provide that instance to the next thing that calls it, and so on and so forth. And I wanted to actually step through this a little bit so it's a little easier to understand. I'm sorry, the presentation's a little bit, we've been running around this morning, but let me see if I can't find a good way to step through this. That's better. All right, so we're gonna debug through this. In my app, essentially, we're asking to get the controller class from our container. And so we're going to go through the process of what that actually looks like when it's registering the classes and then returning them to us. Okay, cool. So instantiate the class map. We start going through the dependencies. So we're using the reflections library. We're going through and we're looking at the class path and we're grabbing all the different injectable classes that we have access to. In this case, it's seeing that there's two different, I don't know why the font down really increased, but we have two different classes that were found as a result of that. And then from here, we go into each of those and we go to register those classes. Let me go to register classes. So once we have the class that we want to get, we check to see the map if it already has it. In this case, we don't have it in the map. And so we go to actually initialize the class. From inside of here, we look at the constructor to see if it has any dependencies before we try to initiate it or instantiate it. So if it has dependencies, we'd enter a recursive loop at this point to see if we have access to those dependencies already within the map that we have to store the classes that we have. In this case, we don't have any dependencies on the specific one. And so we're returning basically a new instance of the class using that constructor, and then returning as an object. That'll go into now the class map that we have, so it can be injected into other things as it gets there. And we'll continue. So again, we're going through, we're looking at anything that it has that needs parameters. As it's done, we'll put it in the class map, and then so now that we've actually registered these two classes, their constructors didn't require anything. We go back to the controller, and we're actually using inject on a field here, meaning just like in Spring, how you do an auto wire, we can inject a field. And so basically now that we're asking to get an instance of that controller, we're wanting to make sure before we actually return it that we provide all the fields that it has. And so basically it's going to go through and it's going to initialize the field that it has. There. And then inside of it, it's basically going to do the same thing. It's going to go to our class map. It's going to find to see if it has the field already present. In this case, it's trying to get the service, and then it's going to register that service and pull it back to and put it inside of the our. There you go. So it goes, it finds the field. In this case, it's the service that it wants. And then it goes to our class and it actually says, go ahead and give me the type of the field on that class. So specifically which field it needs. We're going to go through and then we're going to set that field based on the instance of the controller that already exists. We're going to provide it the instance of the field that we got from our container. And then finally, it will go ahead and return our controller. And then finally, we can see that we get our controller classes available here. It's got the service available on it. And then we're basically printing out the method on the controller that implements or uses the service. And then we get our output. Yeah, that's basically the demo there. I know that was a little shaky. So if there's questions I'd love to address or parts of the code that you want to go over, I'd be more than happy to do that. But again, just to recap, I guess, at the high level, right? We're creating that context that's going to hold all the classes that need dependencies throughout our application. We're going through and then we're scanning for which dependencies we need to register. We register those to the context. And then at runtime, we're providing those fields to the classes as they become available and managing that outside of any of the classes within our application so that each of those classes can have a layer of separation from each other and not have to worry about providing those dependencies in sort of like that tree-like structure that we saw earlier on. Yeah. Any questions about that?
Yeah, I'll start.
Yeah.
I was interested in the interface path.
Yes.
Is interface and what happens if there is an interface?
Yeah, that's a great question. So there's a couple different answers to that, right? What?
Can you rephrase the question?
Oh, yeah, for the audience, sorry. For those online, the question is what happens when there's an interface, since you can't just instantiate an interface, there has to be a class that implements it. So that's a good question. If I built this out a little bit more, we'd have basically like perhaps like a blueprint method or a template method that would return what the interface should use. In Spring, we've got a couple different ways of handling that. In here, basically what I did is, let me pull it up here. So what I did in here is services, interface. So I have two services that actually implement the interface. I'm only using one here, but what it does is when there's an interface and it's trying to figure out which class to use for it, there's actually a separate method that was created here. Yeah, so it's called getInterfaceInstance. So basically it's saying, hey, I see an interface. I know that wasn't registered because I can't inject an interface directly. So that @inject annotation, or injectable, I should say, the @injectable annotation that was created, it can only be put on like a class. And so basically when we see an interface, we take the type and then we say, okay, let's look through the class map that we've already registered our dependencies to, and then see if any of them actually has an interface that it implements that matches the interface that we're looking for. So out of all the interfaces that it's implementing, let's see if it has that interface in that list. And then if it does, then we'll go ahead and then we're gonna register that instance. But instead of adding the specific class, so in this case, if we're looking at injectable service, but the interface is injectable service, what it's gonna do is it's gonna register to our map the class type of the interface with the object literal of the interface service. And then from there, it'll continue as normal. So it'll say, okay, now I see this interface type, I'm gonna return the instance of that service instead of the interface. So it's just a slightly different way of handling it if it's an interface. And like I said, in like Spring and other frameworks, what it'll do typically is in the auto wire or inject annotation, it'll have an option for a name of the bean that it's going to use. So you can specify which one it's going to use. And basically it's doing the same thing. It just registers it based on the bean name instead of the interface type, like I was saying here. Any other questions?
There are generic frameworks that do this out of the box. Like in other words, looks like you're building it from scratch here, but are there some well-known frameworks that do this type of thing?
Yeah, I mean, Spring Boot does this. That's a big push of Spring Boot. .NET Core does this now. You can register dependency injection. Angular on the front end does dependency injection in a similar way. The idea behind just kind of like actually breaking it down into like a code example was just to kind of get behind the scenes of it. Because by nature, like dependency injection is pretty nebulous. I just put an interface here and an annotation here and an annotation here and it works. And so the idea of like getting down into the context and being able to like dig into that. I'll have this up on GitHub. I know we rushed through like the actual code and it's kind of hard. It's a lot of generics, it's like connecting lines. But be more than happy to share that afterward as an example. And this is by no means like something that's ready to be published to like as a jar to Gradle or anything. It's like use this, but it's kind of like a good example of like how it works and hopefully like get under the hood a little bit and get an idea of what's going on behind the scenes in those. I guess we got 1 minute. So any last questions? If not, I'll try to, like I said, I'll get this up on GitHub. We can share it out, but. Okay, awesome. Well, thank you guys for coming. Thank you for bearing with us.